Hi everyone, in this video we will walk through my ENPM 809T final project. In this project, we're trying to simulate the vaccine distribution and administration by autonomous robotics. So here, we're using this ground robot to deliver a vial to a specific location. So this is my ground robot. It's controlled by this Raspberry Pi module. And this Raspberry Pi module are linked to my computer with Wi-Fi. So I can upload code and give a command. The dynamic parts, this robot have 4 motors powered by the battery over here, and all the motors speed are controlled by this H bridge, and to pick up valves and deliver the valves, I have this robot arm. It's powered also by the battery and controlled by this servo. Okay, first of all, let's talk about this robot design. Start with the hardware on this robot. I use Raspberry Pi Module B to execute my code and program. And for the perception parts, I use this pack camera and IMU to... Raspberry Pi is powerful, but if you connect Raspberry Pi to a monitor, it's gonna slow Raspberry Pi down, and we lose remote control for robot. So here I use SSH to connect my PC and Raspberry Pi. So with this router manager, I can check my Raspberry Pi address and PC address. So here, this is my Raspberry Pi address. Put it into PUTTY, just type it. And this will show me the login page of Raspberry Pi, and I can start with the server. It's already started, so we just go into click continue, type in password again. This will show me the Raspberry Pi main desktop. I just grayed everything out to speed it up. So here, the software I wrote code on is PyCharm. It has a IDE, so I like it. Not like Vim. The language we use is Python, and some default package come with Raspberry Pi, a pack camera, motor control, GPIO pins. So here, in this utility package, I have all the functionality in it. So for the camera class, I defined a camera which is based on the pack camera come with Raspberry Pi, and this will read the video from pack camera. And the color pickup is an image processing class. Has all the functionality I need for HSV masking, color processing, and encoder face 0. I have the functionality to detect a face, human face. Communication, during Grand Challenge, we communicate with robot by email. So this will give me a remote control by email functionality. Gripper is a class that controls the gripper by servo. Ranger is all the perception units, IMU, sonar sensor, the IMU is here, and sensor class. Have encoder here, IMU here. Wheel class to control the wheel speed, rotation, translation of the robot. Grand challenge has successfully picked up the first wheel. And drive to the deliver area. Pick up the RE used for localization. Turn to delivery area. Okay, I just showed my robot a face with my phone, so I have to look the video. Yeah, after a recognized face, we'll drop the valve. And that's where I stopped the grand challenge. After drops the valve, it's reading the red area to localize again. But here it stops on obstacle. This is a graph of my grand challenge traverse. As you can see in this plot, it starts from picking up area of the valve and pick up the valve, go straight and turn right and go straight to the dropping area. After it's dropping the valve, when it's going back, it loses the localization and going directly to an obstacle that stopped my grand challenge. And during this grand challenge, before this grand challenge, my main difficulty I have is the connection issue. In my dorm, the Wi-Fi and Raspberry Pi doesn't work very well together, and I always lose connection after a couple seconds and recover the connection manually. This is really annoying. I have to, before grand challenge, I have to use a internet cable to keep the connection. After that, I bought a mobile Wi-Fi module, and with this mobile Wi-Fi, I can steadily connect to my PC with a Raspberry Pi, which is really helpful.